today we'll be going over Lab 1, also known as the Constant Velocity Lab. So here's a table of contents. So our introduction. So what is this lab? The purpose of this lab is to observe an object moving with constant velocity in one direction. This is done by pushing an object and recording its position using the tracker software. We'll also be making a computer model to simulate the same experiment. So what physics principles do we use? The major physics principle used here is Newton's second law. Newton's second law is the derivative of velocity over time, or you can write it as acceleration is equal to the net force over m. This relates to momentum principle. Remember, momentum is mass times velocity, and momentum principle is the change in momentum over the change in time. In the specific formula, it's in the x direction. So to the lab and the lab data. The lab was set up by pushing an expo marker down a table and using a meter stick for the scale. I'll play the video here. Right, here's the results of the lab. As you can see, the top line is the x direction and the bottom line is the y direction. And here's the graph, again, with both components together. Here's the close group. On the left, you can see the initial conditions, and on the right, you can see where we updated the ball's velocity by dividing F net by the ball's mass. That's to get acceleration, and in this computer example, F net is equal to 0. And then here are the graphs for the computer model. So here you can see both lines, and you can see there's a big discrepancy. But why is there a discrepancy? There's like several factors affecting the real life system, such as friction, force in a different direction, and of course human error. To conclude, what if x was in the negative x direction rather than the positive x direction? I would think this would change very little in the means of the code as instead, and the experiment, as the model will just be in the negative x direction, so to produce a different line rather than the one it did. And why would net force be 0? There's several factors such as like friction and drag, as well as like the surroundings could be not completely smooth in itself. And those can all be factors to consider when trying to get a net force of 0. Thank you.